Dear students, welcome back. This video is on ANOVA summary and writing conclusions and reporting of results. After calculating the sum of squares for treatment and sum of squares for error and then F statistic, we will move to summarize those results in a ANOVA table, what is known as summary ANOVA table. So this table has various components, say source of variation. So this source of variation represents what are the different source of variation we have. So we have only one source of variation, that is going to be the treatment variation, which is caused by the pain management techniques, that we call it as between, and then we will use error sum of squares as a one source, and then you have a total variation. So moving to the second column, it is the sum of squares that we calculated for between treatment, that is 3034.1, and within variation 989.6, and the total variation or total sum of squares is 4020.7, and the degrees of freedom related to the intervention is 2, because we had 3 treatment, 3 minus 1 is 2, and error sum of squares is nothing but n minus k, total observation minus the number of treatment. So we have 12 degrees of freedom related to the error, and then we have 14 degrees of freedom for total, because we have 15 observation, 15 minus 1 will have 14. So now we will compute the mean sum of squares for all these sources. For example, we will first try to find out mean sum of squares for treatment, that is we are going to divide the sum of squares for treatment divided by degrees of freedom 2, we will get 1517.1. and then we will calculate the mean sum of squares for error by dividing the within sum of squares divided by degrees of freedom for error 12. So we will get 82.5. Finally comes to the F ratio, which is the ratio of mean sum of squares for treatment divided by mean sum of squares for error, which we have 18.4. Let us discuss the p-value of F statistic. So the p-value concept is nothing but the probability of obtaining test result at least as extreme as the result actually observed under the assumption that the null hypothesis is correct. Simply, it is nothing but this smallest significance level at which the null hypothesis would be rejected for the given observation. So let us define T observed as our observed value of the test statistic T, and under null distribution of T, if you are going to find out the p-value to be probability of capital T more than T observed. For a left-tailed test, we are going to calculate p-value based on the probability capital T less than T observed. Suppose you are going to test a two-tailed hypothesis, the p-value can be computed using 2 into probability of T more than T observed. For computing p-value, we should need a F statistic value. Let us represent the F statistic value by F observed, which is 18.4. So under the null distribution of F, the null distribution is nothing but F distribution distributed as k minus 1 and n minus k degrees of freedom. So I have already mentioned F distribution, and under the ANOVA test is a right-tailed test. So for a right-tailed test, we are going to find out the probability of F k minus 1 and n minus k degrees of freedom is more than or equal to F observed. So we are going to actually find out what is the probability that capital F is more than or equal to 18.4. So let us look at the distribution of F in the figure, where the p-value is the shaded region. We are going to find out what is the area to the right of 18.4, which has been computed by using this probability. So the logic behind the calculation of this probability is we will use the probability density function of capital F test, so which is more complex. So this statistical packages is going to give you, so the p-value is 0.002. So for the computation of p-value, you require the degrees of freedom for between and the degrees of freedom for error, as well as the F statistic value and the level of significance. With all these ingredients, you may be able to find out the p-value is 0.002. We move to writing the conclusions. So that table is only the output of the statistical packages. Whenever we are reporting the table, we no need to write those tables. It is enough to write the important components present in the table just to make a meaningful conclusion. So, what and all we are going to take? We are going to report the F statistic value, the critical value and the probability value, and the degrees of freedom associated with treatment and within sum of squares. So, we have to see what is a statistical decision we are making. For that, we are going to compare the calculated value with that of the critical value. So, if the F statistic value is greater than the F critical value, we are going to reject our null hypothesis at the given level of significance. So, what we have 18.4 is more than 3.89. So, we are going to reject our null hypothesis at 5% level of significance, and we are going to conclude that there is a difference in the mean anxiety scores between 3 pain management techniques. So, we have actually compared the anxiety score of children who have undergone 3 treatment, let us say musical audio, storytelling audio and then audio visual. So, we will come to know that there is a difference in the anxiety score between the children who have undergone these 3 pain management technique. So, this F statistic will give you an overall comparison of all the 3 groups, but it does not tell us which group is significantly different. For that, in future video we will discuss the post hoc comparisons. Now, we will move to reporting the results. Once you have performed the analysis of variance, you have to report the important descriptive measures from the data, and then you have to say the result of the statistical significance, the result of hypothesis test. So, here this table contains 3 important things. One is what are the variable you are dealing with, and under that variable you have to mention what are the categories and then what is the size of the each category. For example, because of many reasons subject may lost to follow from a study, or you cannot able to measure the scores from those children. So, your size will vary for all these categories. So, it is very important to mention the size of each categories. So, I had enrolled 15 individual, there is no lost to follow up in the patients. So, I have the complete information, 5 in storytelling group, 5 in musical audio and 5 in audio visual. So, in each of this level, what is the mean and the standard deviation of anxiety score I need to report, because reporting this mean and standard deviation will give you the magnitude of the difference, so that whatever conclusion you are make, you can visualize the difference. So, let us say for storytelling audio, we have the mean 25.6 with the standard deviation 11.8, and musical audio 44.4, 9.53, and audio visual 9.6 plus 4.04. So, whatever scale we are looking at, the anxiety score, its ranges from 15 to 75. So, the children, if they are having a higher anxiety level, their score will be higher. If they are facing a lower anxiety level, then their score will be reduced. So, lower the score, good the anxiety score is, so that the doctor can do the procedure in a very well manner. So, we can see that the student who are, so that we can see the children who are undergoing storytelling audio is having the score of 25.6, whereas the musical audio is having the score of 44, and audio visual group is having the score of 9.6. So, from this itself we can able to come to an idea that the musical audio is not reducing their anxiety level during the procedure, whereas the audio visual technique is having a better effect on their anxiety score, because it is giving a very lesser score. Now, we look at the standard deviation, how far these scores are varying. So, after presenting the summary measure, we are reporting the significance level, that is our p-value, which is produced from the statistical package. So, we are getting a p-value 0.02. So, how to interpret based on a p-value? So far, I have introduced how to make a statistical decision based on a critical value. Now, I will discuss how to make decision about the hypothesis based on a p-value. So, if you have fixed your alpha level as 5%, that is 0.05, you have to compare your p-value with the level of significance. if your p-value is less than 0.05, you are going to reject your null hypothesis. So, in our example, the p-value is 0.002, which is very well less than the alpha level 0.05. So, we are going to reject the null hypothesis and conclude that there is a difference in the 3 pain management techniques. After reporting the result in the tabular form, we need to write the results in a text format also. Whenever we are writing a thesis or any article, we will also report the discussion and result after the table. So, from the p-value, since it is less than 0.05, we have rejected our null hypothesis. So, we have to write there was a significant effect of different methods of pain management technique on the mean anxiety score by representing there what is ANOVA table value and what is the F statistic value and what is p-value. So, though you have already represented in the table, it is also must to report the p-value in the text also along with the test statistic. Overall, in this lesson, we have understood how to apply the concept of one-way ANOVA to the real-life scenario. And we have also understood the computational background of the various sum of squares, F test and getting the critical value from F table and how to find p-value. Also, we have discussed how to interpret the results we have obtained and how to report it using table and in the textual form. We will continue in the next lesson. Thank you.